The number e is a number that occurs in nature and is a frequent base for exponential and logarithmic expressions. It's defined by the limit as n approaches infinity of 1 plus 1 over n all to the n power, which when you end up plugging that in and seeing what happens, so remember what limit notation means is that we're looking at this function as your n value gets extremely large and what that function is approaching. So if you start to look in your calculator and you actually put this function in your calculator, and you look at values of n, you can look at the table and see what happens as your n values get larger and larger and larger. You'll see that this ends up approaching approximately 2.72. So remember we learned about that number pi back in previous math classes, where pi is an irrational number and it's approximately 3.14. So e is an actual special number as well, and that number is approximately 2.72. Now we can see the graph of e to the x, and it looks a lot like the graphs of the functions that are given by y equals 2 to the x and y equals 3 to the x. You can see y equals 3 to the x in pink, light blue is 2 to the x, and you can see that e falls right in between them, a little bit closer to the 3 to the x, which makes sense because y equals e to the x is about y equals 2.72 to the x power. So that makes sense that that graph is right in between those two. Let's solve some equations that involve e. So remember what we learned about earlier is that if we can write things where they're both the same bases on either side of the equation, of the equal sign, then we can just set the exponents equal to each other and solve. So looking at this problem, you can see that I have e on both sides of the equation. E is written as the base. So now we can just set the exponents equal to each other, and we get 3x equals 2 minus x. Get all of the x values on the same side, and we get that x equals 1/2. In 1990, the population of Oregon was 2.84 million people. In 2010, the population of Oregon was 3.83 million people. Let P of t be the population of Oregon in millions, where t is the number of years after 2000. This can be modeled by the formula P of t equals 3.298 e to the 0.015 t power. According to this model, what will the population be in 2020? So we're solving for P in the year 2020. Now t was the number of years after 2000, so that means our t value for 2020 is 20. When I plug 20 in for t, we get 3.298 e to the 0.015 times 20. And when I enter that into my calculator, I get 4.45 approximately. So that means in 2020, the population of Oregon will be approximately 4.45 million people. Letter B states, according to this model, when will the population reach 4 million people? Use technology to solve this. We can do this on Desmos by first plugging in what the formula is. So our original formula is P of t equals 3.298 times e to the 0.015 t power. Okay, Now we want to see when this population is going to reach 4 million people. So that's when P of t equals 4. So what I'm going to do is I'm going to actually just type in y equals 4 and see when these two lines intersect. I'll have to end up scrolling around here. I'm going to zoom out so we can see all of our function. So this red line stands for the formula for the population, and the green line is y equals 4. We can see those intersect right at this point here at 12.865. So that means that about 13 years after the year 2000, the population will be 4 million. So 13 years after the year 2000 is 2013.
Find an algebraic rule or formula for an exponential function that passes through the points -1, 8 and 2, 1. So remember that exponential formula is going to be y equals c a to the x. So we need to find our c value and our a value. So what I'm going to do is I'm going to set up two equations using these points. This is my x value and my y value, and again, x and y. So if I set up these points, we would get 8 equals c a to the -1. And in the second one, I would get 1 equals c a squared. So there's a couple different methods you can use to solve these. I'm going to show you guys the method that I have found students prefer the most, and that's doing this division method. So what we're going to do is we know that these are both two equal statements. So what we're going to do is we're going to actually divide them. And the best way to do this is to have whatever one has the lowest exponent, which in this case is this equation because -1 is smaller than 2, to put on the bottom. Okay, so we're going to set that up. So we'll put the higher degree exponent on top, divide that by the smaller one on the bottom. Now by doing that, what's going to happen is we're going to get 1/8 on the left-hand side, and you can see that these c's are going to cancel, and I'm going to be left with a squared over a to the -1. Now remember from properties of exponents that if you have something to a power divided by the same base to another power, I can subtract those exponents and write it as one base. So by doing that, this is going to give me 1/8 equals a squared minus -1. So 1/8 equals a cubed. So now to get that a by itself, I'm going to do the cube root of both sides. Which leaves me with 1/2 equals a. So now I have the a value. To find the c value, I can plug it into either one of the original equations that we started out with and solve for c. So I'm going to end up using this equation just because of the fact that I've got positive exponents, and I think usually those are a little bit easier to deal with. So let's go through and do that part now. So I've got 1 equals c a squared. So 1 equals c times 1/2 squared. So 1 equals c times 1/4. So to get the c by itself, I'm going to multiply both sides by 4. And I end up getting that 4 equals c. So now I've got my a value, I have my c value. So now I can write out the equation, and it's going to be y equals c times a to the x.